Hello everyone, my name is Huiling Zhao. Today we study the Functions 11, Chapter 1, Introduction to Functions. 1.6, Exploring Transformations. For the transformation, the general form is y equal a f k bracket of x minus d and then plus c, where a, k, d, c are parameters. They are real numbers. The rule: a, k change the shape of the graph. D, c change its position. On the other hand, a, c change y value. K, d change x value. What is a, k, d, c? How to change the graph? The value of the a determines the vertical charge or compression and whether there is a refraction in the x-axis. When absolute of a more than 1, the graph of is charged vertically by a factor of absolute of a. When absolute of a more than 0 and less than 1, the graph is compressed vertically by a factor of absolute a. When a less than 0, that means is the negative. The graph is also reflected in the x-axis. Next is talking about k. The value of k determines the horizontal charge or compression and where there is a refraction in the y-axis. And when k absolute of k more than 1, the graph is compressed horizontally by the factor of 1 over absolute of k. When absolute of k more than 0 and less than 1, the graph is charged horizontally by the factor of 1 over absolute of k. When k less than 0 is negative, the graph is also reflected in the y-axis. Next, talking about the d. The value of d determines the horizontal translations. For d more than 0, the graph is translated d unit right. For d less than 0 is negative, the graph is translated d unit left. Next, for c. The value of c determines the vertical translation. For c more than 0, the graph is translated c unit up. For c less than 0, the graph is translated c unit down. For example 1, the parent function is gs equal the square root of s. The new function is fs equal negative 3 times square root of 2 bracket s plus 4 bracket and then the minus 1. State the transformation. Solution. We know that a is negative 3 and k is positive 2, d is negative 4 and c negative 1. The transformations are: number 1, refraction in the x-axis. Because a is negative. Number 2, vertically charged by the factor of 3. Number 3, horizontally compression by a factor of 1 over 2. Next, translation for units left. Last one, vertically translation 1 unit down. Example 2. From the parent function gs equal the square root of x to the new function fs equal negative 3 times square root of 2 and bracket x plus 4 and then the minus 1 and the same function like example 1. And whole question number A, determine the corresponding points. B, graph the function. Solution A, from gs equals square root of a x to the new function fs equal negative 3 times square root of 2 times the whole term, the x plus 4 and then minus 1. Find the corresponding points in the order of k, a, d, c. You can see the first column is for the original function. There are 4 points. And the next column is put the k in the function at f2x. And then the third column is also put the a in the function. Is 3 times f and then 2x. The next column is put the negative, or a is negative 3 times f 2x. And next is also put the d in the function is negative 3f 2 and times bracket x plus 4 in the bracket. And next column is negative 3f2 and times the whole factor x plus 4 and then the minus 1. We identify one by one. For the first point 0, 0 and consider the k is 2, so the point change into 0, 0 is the same thing because here this k is 2 and for the here the k influence x value, so 0 times 2 is still 0, so this point is 0, 0. And the next, and put the a in the function is 3 f2x, so the a change y. Here 0 times 3 still 0, so the point is 0, 0. And next is put the negative for the a, so the point is 0, 0. And next put the d, negative 4, so the negative 4 that means change the x value, so 0 minus 4 is negative 4 and the y value no change. Last column is put the c together, is c is negative 1, so they change y. That means 0 minus 1 is negative 1. And the second point, 1, 1. And similar, f2x is change, this k change x, so 1 over 2 is 1 over 2. And no change y. And next put a is 3, so a is influence y. So here the 1 times 3 is 3. So the point is 1 over 2 and 3. Next, a is negative 3, so the y is changed into negative 3. Next, put in the d. D is negative 4, so d is change x, so that here is 0.5 minus 4 is negative 3.5 and the y value no change. And last column is put the c, negative 1, so the c is change y. That means negative 3 minus 1 is negative 4. The next point is 4, 2. So first column like f2x, and then the k here the change x. That means 4 divided by 2 is 2. So the point is 2, 2. And the y value no change. Right? And the next is 3 f2x. So this a is 2. So a is change y. That means 2 times 3 is 6, and the x value no change. And next put the a is negative, so y change it into negative 6. And next put the d is negative 4, so d is change x. So here 2 minus 4 is negative 2. The point is negative 2, negative 6. And next, and put the c is negative 1. And then here the c is change y. That means negative 6 and minus 1 is negative 7. The point is negative 2, negative 7. Last point is 9 and 3. And f2x, this k is 2, so change x. And 9 over 2 is 4 and 1 over 2. The y no change, still the 3. And next put the a is 3, a is change y. So here 3 times 3 is 9, and x no change. And next column is negative 3, a is negative 3, so the y change into negative 9. And next put the d is negative 4, and d change x, so that here is 4.5 minus 4 is 0.5, and the y value no change. In the last column is put the c negative 1, that means change y. Negative 9 minus 1 is negative 10, and the x no change. Above we show the point from the original function to the transform function. Get a corresponding point. Solution C is scratch the graph. You can see the graph from the original function. That means the parent function y equal the square root of x. And next here they put the k is 2, so get the here is the blue one. And here they put a is 3, get the y equals 3 times square root of 2x, get this one. That's the green one. And next the change a into negative, that means a is negative 3, so let's get the purple one. And next put the d negative 4, here this one is the green one. And last one is put the c negative 1, so get y equal negative 3 times square root of 2 and times the whole factor x plus 4 and minus 1. That's the last function. Example 3. Applying transformations to the equation at the graph. Some transformations are applied in order to the reciprocal function fs equal 1 over x. There are 4 steps to transformation. Number 1, horizontal strategy by the factor of 3. Number 2, vertical strategy by the factor of 2. Number 3, reflection in the y-axis negative 1. Next, translation 5 units right and 4 units up. There are 3 questions. Number A, write the equation for the final transform function. Number B, scratch the graph of fs and gx. Number C, state the domain and range of the both functions. And the solution A, determine a equal 2, k equal negative 1 over 3, d equal 5, c equal 4. The transform function is gx equal 2 over the whole denominator at the negative 1 over 3 and times the factor x minus 5, and then plus c is 4. Or we can simplify like that: gx equals negative 6 and over the whole 1 x minus 5 and then plus 4. The two expressions is same equally. And b, scratch the graph. The parent function blue one, and here the blue one, and the new function is the gray one, this one and this one, the two branch. For new function domain, x belong to R, the real number, and x not equal 5, because here is the numerator, the denominator cannot be 0, so that means s cannot be 5. And the range, y belong to R and y cannot be 4. And for the parent function, domain is x belong to R and x not equal 0. And the range is y belong to R and y cannot be 4. This is the parent function of the parent function. The range is y not equal 0. Example 4. For fs equals s squared and the transformed function is gs equals 3 times f the whole 1 negative 2x plus 4 and plus 1. There are two questions. One, identify the parameters like a, k, d, c, and b, scratch the graph fs and gx. Solution A. For the parent function fs equals s squared, the transformed function is gx equals 3 f the whole x is negative 2x plus 4 and then plus 1. So we have to take the negative 2 out, so become the 3f bracket negative 2 and bracket s minus 2 bracket plus 1, according to the standard form or the general form. So we can identify the x equals 3, k equals negative 2 here, and the d is positive 2 and c is 1. So the exact function is gx equals 3 and the prefix square inside 1 negative 2 times x minus 2 bracket, or change into gs equals 12 times prefix square x minus 2 and then the plus 1. The two function is equal. Then the a is 12, k is 1, d is 2, c is 1. And scratch the two function. Like this one is the original function, that means a parent function, and the purple one is the transform function. We can see the symmetrical line is x equal 2. And the graph move to the right 2 units and move up 1 unit. Example 5. Identify the parameter and scratch the transform for f gs equal negative 4 and times absolute of x plus 2 and then the plus 1. Solution. We compare the parent function and the transform function. We can see that a is negative 4 here and k is positive 1. D is negative 2 and C is positive 1. And the scratch here. You can see this one is fs equal absolute of x. And the red one is the transform function. We can see for the vertex is from 0, 0 to here is negative 2 and 1. So they move to the left 2 unit and move up 1 unit. Also change the shape because here the a is negative 4, so its shape is changed also. All above we explain the transformation for the linear function, quadratic function, square root function, and absolute function. Thank you for your watching and listening. Please share the video to somebody who want to study the course. Thank you very much. Thank you. See you next time. Bye.